As a reminder, for more Microsoft webcasts, you can visit Microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communication Foundation top to bottom. Today's session is part 10 and 15, Security Fundamentals. And now, without any further delay, I'm going to turn the floor over to our presenter, Michelle LaRue Bustamante.
Thank you. Welcome, everybody. And here we are again with yet another installment of the 15-part series. And today I'll be talking about security. My name is Michelle LaRue Bustamante. I'm a regional director for Microsoft and an architect with iDesign. And you may also know that I just completed a book called Learning WCF, published by O'Reilly. And the code for that book is entirely downloadable from www.indigogirl.com, which you see at the bottom of this screen. So that will be the code samples that I'll also be using in this and the other webcasts. And then, of course, my other blog, DustBlind, is another resource you want to make a note of on this particular slide, just so that you know where I'm posting other potential code samples and such. Today, I'm going to be covering security. So we're going to start by discussing some of the core settings for WCF and security. Security is a rather large subject in WCF. There's a lot of features to it. I do have to assume that you have some knowledge of what security issues may come up in an enterprise system in order to go forward with the WCF specifics. Because we're going to jump into things like the binding settings, so I need to know that you understand bindings already. And we'll talk specifically about the settings for security in each of the common bindings for deployments. We'll talk about scenarios like intranet and intranet. We'll talk about B2B scenarios with certificates and so forth. We're going to talk about authenticating with different types of credentials like Windows and certificate and username. I will not get into claims-based security in this webcast. I've actually reserved an entire webcast for that following this one. And then we're going to also talk about authorization, of course, of those credentials against either the Windows domain or custom credential stores. So the goal of this is to give you the foundation, basically, of security with WCF for the most common scenarios. The prerequisites, again, is that you have familiarity with .NET, of course, that you understand how to build a WCF client and service and consume it, and basically how to configure a binding, and that you have some understanding of security issues. And so this will be the agenda in the order we'll go through it. We'll start with some core security concepts. We'll talk about the specific settings that WCF has to offer. I'll talk about controlling the protection level and also dealing with credentials and mutual authentication. We'll talk about certificates and Windows credentials. We'll talk about username, password credentials, and the relative, the more popular configurations for those deployments. So starting with just some core concepts behind security that we'll be discussing, mutual authentication, of course, refers to the mechanism whereby the sender and the receiver of a message, let's say, can identify one another. So we need to know that, for example, when I'm sending a message to a service, that I know I'm really sending the message to the service that I trust and not to some other endpoint. And then likewise, of course, the service will usually authenticate the call, so it needs to know the message came from a trusted source. Now, authorization refers to what am I allowed to do once I have been authenticated. So this refers to the rights that I have. Typically, we think about role-based security, although that's not the only way we do authorization. So I'll talk about a few of those things today. Confidentiality refers to the ability to, of course, hide the contents of the message so that only the ultimate recipient is allowed to see those contents. So we refer to encryption when we talk about confidentiality. And then integrity has to do with making sure that we know nobody tampered with the message between the point where it was sent from the sender and the point that it arrived to the ultimate receiver, which is the application. And the way to do that is using digital signatures. So we'll talk about how to do that as well. Now, fortunately, all of these things are actually pretty simple to configure. The more important part is that you understand what is it you want before you go to choose the configuration settings. So that's actually more of the difficulty than it is to actually do the work with WCF. And then another feature that WCF does have as a core feature is the ability to prevent replay and denial of service attacks by checking timestamps of messages, for example. So that's an aspect of security that relates to reliability as well for the system as a whole. We often do replay detection and denial of service prevention at the firewall router as well, and that's something that should still be done even if the application is able to support it. And I really won't spend more time on this, given that we only have an hour talking about what's built into WCF. Just wanted to make sure you knew that there was replay detection also built in. So let's talk then about authentication and authorization, just to make sure we're clear on that. So this implies that I'm passing credentials to identify the call. And in today's discussion, we're going to focus on Windows tokens, certificates, and username and password. There are other types of tokens or security tokens that you can send, but we'll get into those later. And then we also need to know that we're sending the message to a trusted service, and that can be done using a Windows token, for example, or a certificate. When we're on a Windows domain, Kerberos will supply us with that authentication as well. And then authorization against the appropriate credential store refers to the ability to gather the roles or the permissions or other access rights. And so, for example, if we're on an Active Directory domain, we might think about the groups that the Windows credential belongs to. Another thing that we need to think about with security, besides authentication and authorization, which should be pretty straightforward, is transfer security. So this is referring to how do we protect messages while they're transferred from being tampered with and also from being viewed by malicious parties. So we need to protect it not just across network nodes, but between actual application nodes and possibly across interoperable boundaries. And there are ways to do this by enabling encryption and digital signatures, or encryption and signing as we call it. And we can do that either on the wire, which is using transport security, like SSL for example, which is point-to-point, or message security, which means we protect the actual contents of the message no matter how many network nodes it traverses. Just to give a perspective on that, when we think about transfer security, if it's transport, then I might be using SSL, for example. IPsec and TLS are other examples of this. And of course, WCF has built-in transport security for name pipes and TCP and MSMQ. And this is only point-to-point, which means that it encrypts the entire contents of the packets that are sent between sender and receiver. So you don't have the ability to encrypt some parts but not all to reduce the bloat. You encrypt everything on the wire. And it's only safe from point to point, which means that if there's any sort of intermediary, for example, an application router in the center, then we wouldn't be able to protect the hop between the intermediary and the receiver, or at least we cannot guarantee that unless we own it. So where message security comes in handy is in the ability to actually secure the message itself. And so the message is what is encrypted and signed, or parts of it. And the intermediary may not even be able to decrypt that message because they may not have the correct keys to do so, which means that we actually have secured the message all the way through to the ultimate receiver. So this is pretty powerful, and it's also interoperable. So to sum it up, the things that we're talking about in this session is how do I do authentication and authorization, but also how do I affect transfer security of the message using either the transport or using message security, and when might I opt in for each. So we'll go through some scenarios as I get into the details. So the WCF security settings that we're going to be discussing include security mode, protection level. We're going to set up client and service credentials, and which are required. We're going to talk about impersonation. We're going to talk about negotiation of credentials and secure sessions. We're going to talk about authentication and authorization behaviors and how you control where we're going against in order to do authorization, for example. So let's talk about the security mode first, because this is the first and foremost setting that you will decide upon when you configure a WCF binding. So essentially what happens is, a binding is an address, A, a binding, which is a set of protocols, B, and then a contract, C. And every single endpoint, the binding, is what controls how we are protecting the message and what credentials we require on more or less both ends. So when we're using transport security, we configure that in the binding. We say we're going to use SSL, for example. If we're using message security, we configure that on the binding. And what that really says is the settings you should look at, the WCF runtime should look at when it configures the channel, should be the message security settings instead of the transport security settings. So we have a choice of which settings do you want to look at, which settings do you want to use, and of course they have to be equivalent at both sides. So the client has to agree with the service on these protocols, right? And so security mode then, if you're using transport security, which would be typical of an intranet application or a machine-to-machine call behind the firewall, we might use NetTCP binding because we want to use binary encoding, which is more optimized. And we would set the security mode to transport. And we would probably maybe be using Windows credentials, for example, if it was an intranet application. We just want you to log into your domain. And this is actually the defaults. What you're looking at right here are the defaults for NetTCP binding. So in fact, we could just use the defaults if we know we're using an intranet application. Notice that security mode transport means that I'm working with transport security settings, which means anything I put in client credential type here is what will be used to configure the channel. By comparison, if I use message security settings, then it's the message section that should be populated. You can populate both sections, but only one will be used. The other will be ignored because of this mode setting. Now, unlike TCP transfers, when we use HTTP, we're usually going to default to message security, although that's not always required. That is the default for WSHTTP binding. And so the default for HTTP binding would also be Windows credentials, but we would usually switch that to a username password because typically in an internet application we don't have a Windows domain that we're logging into. We just have a custom database, for example. Or we may support both. And so what we do is we allow users to pass the username password, and it could be a Windows credential or it could be a custom credential. We can figure that out on the back end. And I'll talk about that a little bit later when we go into authentication and authorization settings. The point is that we default to message security, which means we're using the message to encrypt and sign, and we are passing credentials as part of the message instead of as part of the protocol headers. Now, it's also possible you might want to pass a username password in the message, but you may want to use the transport to do encryption and signing. And so in that case, we can use this setting called transport with message credentials. That would be typical of basic HTTP binding, for example, when we do a classic web service as we know it today, which is I pass the username and password using interoperable protocols, which means I use the message, not the transport, typically. And I use the transport, which means I have to have an SSL certificate installed in IIS for this to work. And we'll see an example of that later. So to sum it up, these couple of slides really just talk about, hey, I should know ahead of time which security mode I'm planning on using. Typically, intranet is TCP, and it's going to be a transport security. And typically, if we're going outside the firewall, we're going to use message security if we can, just because that does secure the message better than point-to-point, because it means the message itself is protected all the way through, even if we pass it through some sort of routing configuration, which is becoming very popular for managing web services behind the enterprise. So, given that we're talking right now about configuring which mode do I use, transport or message security, the thing that we're controlling here, or could be controlled here as well, is the level of protection. Do we want to encrypt and sign the message, or do we want to just sign it, or do we want any protocol protection? Now, typically, you want to encrypt and sign, and that is the default. When you turn on security, by default, you get encrypt and sign protection level. So by default, this is a good thing if it's a secure binding. Only basic HTTP is the binding that has no security, but as soon as you enable security, you get encrypt and sign. You can throttle this setting so you can actually reduce the level of protection if you like. Why would I do that? I probably wouldn't. Could there be minor performance benefits because you reduce the bloat of the message? Perhaps. I would only do that if I knew that the wire was secure. So I'm at least encrypting and signing somewhere, either on the wire with IPsec or with the message itself. You should have one or the other, especially in today's day and age of litigation of data transfer. So unless you actually are dealing with completely unimportant data, and what real enterprise application has unimportant data, then I would say you're definitely encrypting and signing. With that said, I do want to explain how you can require a minimum level of protection, and also, if you needed to, how would you change the protection level option. So starting with transport protection, if we are using transport, like TCP bindings, there's actually a protection level setting in the transport security section. So I could change that from encrypt and sign, which is the default, to sign only, as you see here. And MSMQ bindings have their own settings for that, which I'll talk about when we get to message queuing, which is another webcast, by the way. So we can't throttle if you're using SSL. So if I'm actually using transport with message credential over HTTP and I'm hosted in IIS with SSL, I don't get to choose whether I encrypt and sign. I am encrypting and signing. You cannot reduce that. But when we're talking about TCP or named pipes or MSMQ, we do have that ability to control it. Why would I do that? Again, maybe because I'm on an IPsec system or network. Now, the other thing that I can do is for message security, instead of having a setting in the binding as I just showed you with transport, there's actually an attribute that we apply in the operation contract you see here, protection level. And so what happens is if I set the protection level to anything other than encrypt and sign, it will reduce the level of message security if I'm using message security only. If I'm using transport security, this will not change that setting. It only works on message security. However, this attribute has a double role. One of its roles is for message security to control if we sign and encrypt or not. The other is to require a minimum level of protection on the binding. So what this is really useful for is for you to require that when you deploy this particular contract implemented on a service, you have to be on a secure binding, and that is very powerful. So with that, let me actually go into a demonstration of it, and we'll talk about that a little bit. So I'm going to share my desktop, and we'll go to a simple example here. Now, in this example, right now, I have a service which just has a regular operation contract, and currently it's deployed on a TCP binding. So let's take a look at that. Here is my binding, NetTCP. And what you can see as well is that I'm using transport protection with the defaults of encrypt and sign. And the client is configured exactly the same because I've already pre-configured it. So I'm just going to give it a run and show you that it works first. And you see that it works. Nothing up my sleeve, right? So we're done. Now, if I were to make a change, for example, to the client, keep in mind I'm doing TCP binding right now. So let's see what we've got here. Right now, my protection level is using the default. If I change it to sign only, what's going to happen is the client is going to send a message and only sign it but not encrypt it. And the server is expecting an encrypted and signed message. Vice versa on the response, right? The response only expects a signed message, but it's going to come back encrypted and signed. That is, if we actually made it through the round trip, which we won't. So let me run this, and I'll show you what happens. We're going to get an exception that the requirement was not fulfilled during authentication. Try increasing protection level. So that's a fairly intuitive message. We like that. I'll stop debugging. And now let's go to the host, which is the service, and let's change it to be the same. So now they're equivalent. That means that the bindings understand each other, and when I run this, it should work, but instead of encrypting and signing, it will only sign. Of course, this is happening at the wire level, so we can't see that it did it or did not do it, because unless I did a trace, using TCP trace or something like that, we might be able to decipher the size difference. At any rate, let's take a look now at what happens when I modify my operation contract. And what I'm going to do is set the protection level. And I'm going to set that to protection level dot encrypt and sign. Now, what does this do? Well, it has no effect on whether or not we use TCP encryption and signing, but what it does do is it says, hey, when you deploy this service, I require you to encrypt and sign messages, so the binding has to comply. And so what's going to happen is I'm going to get an exception saying the request message must be protected, so administrators can't deploy your high-risk services without a good binding, and this is a great thing. Really, really, really good thing. Now, let's take a look and see what happens when I change the binding on both the client and the service. So we'll start with the service. And I'm going to remove the TCP binding, and I'm going to use WS HTTP binding instead. And so if I use the defaults for WS HTTP binding, that would encrypt and sign by default. So basically what we'll do is just go to the defaults on both ends. And what I'm going to do is run the host, or actually go to set that as a startup project. And while that's running, I'm going to go back and update my service reference. So that's going to update my configuration at the client so that I'm now using WS HTTP binding. You see that here. It's expanded the binding, but somewhere down here we'll see that we have a new endpoint, and that endpoint is the HTTP endpoint right here. So I'm going to go ahead and actually comment out the TCP binding just because then we don't have to change the client code, and it will just pick up the default endpoint. So our code in the client does not change. And we'll compile that and give it a run. So the default works, and that is basically just WS HTTP binding on both ends, passing a Windows credential. So if we take a look at the attribute here, not only did we require that we were on a secure binding, but we actually are indicating we want to encrypt and sign for that binding. And if we change that to sign only, and we have to do it, of course, also in the client proxy, because, by the way, this is part of the metadata, so it actually gets carried over to the client, you'll see. If it refreshed it properly, I might add. So it's possible that it didn't refresh that as we might have expected, so I'm going to go ahead and type it in manually. But when you carry this over by default, that's what it would do. And this will be protection level sign. And I think I'm going to need to add a reference here to my proxy using system net security. And away we go. So I have to have the same on both ends, otherwise I will be encrypting and signing by default from the client. And although I won't be enforcing anything, because without this it won't enforce that the binding is a certain level of security, it will still do default encrypt and sign unless I modify it. For message security, of course. So let's go ahead and run the host again. And we'll run the client again. And it works. Now, we didn't see anything interesting here, but what I want to show you is that because I was tracing this, I'm going to open up the Service Traced Viewer, which is the utility that comes with the SDK, and I'm going to open up my protection level log. So this tool will show us all the messages that just happened. And if we get down to the bottom here, what you'll see is the last Hello Indigo, and I'm going to go to the XML of the message, so just bear with me while I get there. Okay, so the last Hello Indigo, as you can see here, the body of my message is not encrypted, but it is signed. You see this ID here? It is signed. I'm not going to go into the details of how digital signatures work. We certainly don't have time for that in this hour. Now, likewise, if we take a look at the message right before that, you see that? Cipher data? It is encrypted. So let me just scroll this over here. And you can see that the body has been encrypted and signed. So that is just showing you that, yes, message protection did indeed throttle what our settings were. So two things about protection level. One is that it allows you to require a level of protection when you deploy, and that's a good thing. And two is that it actually throttles message security. Somebody is asking a question about name pipes not crossing the machine. It's just two services, same station, and yes, that is true. Now, by default, it will encrypt and sign, but you can throttle that down so that it does not. Why would you want to secure calls on the same machine across process? Because anytime you cross a process boundary, there is a risk that malicious code could be running and sniff the message. So if you're in a high security environment, and you're worried about things like Sarbanes-Oxley, you're in a banking industry, financial industry, health care, anything of high risk, then you want to secure it whenever possible. And I guess another way to put it is secure it until somebody complains. Unless you're not getting adequate performance, there's no reason not to secure it. And then another person asking if there's the difference between message and transport security. Transport security is protecting the message on the wire, meaning that we're protecting the actual packets that are sent on the wire, as opposed to the SOAP envelope, which means I can choose which pieces of the envelope in the message that I encrypt and sign, for example. Transport and message security also refer to how do I pass credentials. When I'm using HTTP, I can pass credentials in the HTTP headers, which is part of the protocol, transport, or I can pass a username password inside the message as part of the message, which means that it doesn't matter if I go from HTTP to TCP, I can move that message around and it carries all the credentials. And someone else asking if I'm going to cover the trace viewer in the series. Actually, no, we don't have a webcast dedicated to the trace viewer, but it's fairly easy to work with, so you might just want to email me your question. Okay, so let's continue. I'm going to talk about client credentials now, and we're going to go through some scenarios for different usage. So there are different options for sending client credentials. You can send a Windows credential on a domain, for example, or just a work group. You can have username and password, which is interoperable, by the way. You can have an X509 cert be your identifier. And you can have SAML tokens, which are XML tokens that can carry detailed claims and other related information. In fact, you can customize with custom XML tokens as well, or custom binary tokens. You can really extend the environment quite nicely, but these are the most common. I'm going to talk about SAML and claims in the next webcast, so we're going to focus on the first three for now. Each binding, TCP, name pipes, MSMQ, HTTP bindings, has their own options for which credentials they support. Not all bindings support all credentials, so there's going to be typical scenarios for each of these, which I'll go through. There's also service credentials, which is, again, the service identifying itself to the client so we know the message is not being rerouted to a malicious target. So a Windows credential will do if we do one of either a Kerberos domain, which identifies itself on the domain, or if we use Windows SPNeGo, so negotiation protocol whereby the client and service communicate to negotiate each other's identity on a work group, for example. X509 certificates can also be used to identify a service, and actually those are required when we use non-Windows credentials. So if the client is sending a Windows credential, then we can use Windows credentials to identify the server. If a client is using a username password or a SAML token or a certificate, then the server has to provide a certificate in some way to protect transfer and to identify itself. Okay, so now the first scenario I'm going to go through with credentials is intranet. So your typical client server, N-tier, intranet application will use Windows credentials to mutually authenticate the client and service. The authentication and authorization will go against either the Windows domain or the workgroup. So there's Windows membership and role providers. In fact, the defaults will do. By default, WCF always goes against those providers for Windows, unless you make a change, and you'll see that. The messages are always encrypted and signed at the transport by default, if you're using transport. And the service will have the ability to implement role-based security against the Windows credentials, Windows groups, for example, to protect operations. Usually we will not use impersonation at the service because the identity of the user is usually less meaningful as we go further downstream making calls. So it's usually better to use a trusted subsystem model whereby we have these services downstream, for example, that have the right to talk to the database or other resources on the network. And those services are a layer beneath the entry point service, let's say the web service at the top. And then that way we have the ability to have a layer of protection, if you will, between potential malicious code that runs on the web tier. So in other words, impersonation is usually not used, so I'm going to show you an example that does not use that for now. So let's go to the desktop again, and this time I'm going to show you a different example. So basically this example is a secure service. I'm calling it that, and it's got 3 operations, one for admin, user, and guest. And each of the operations, admin, user, guest, just displays some information. It returns a formatted string that tells us a couple things. One is, what is the current Windows identity of this process? And 2 is, what is the primary identity of the call? And that is available through the service security context, which has a static current, and that is the context for the operation. So this is part of the operation context. We can always get at information about the service security context, including the primary identity, the Windows identity if applicable, and also the claims, which I'll talk about in the next webcast. Now, this service is hosted right now as TCP. So my endpoint is a NetTCP binding using the defaults. And that's that. What are the defaults? Windows authentication. So what's going to happen is the client is already configured, and you can see it's configured with Windows authentication, encrypt and sign, transport protection. Those are the defaults. So what's going to happen is I'm going to run the application. The client is currently running as Michelle, that's me, and if I call an admin operation or a user operation or a guest operation, I get in. And you'll see that the console has dumped out that the host identity is Michelle. That means that my host is running as Michelle. Why is that? Because it's a console host, and it was run with my identity on the machine. So if I was running an IIS, it would be network service. That identity is important because that governs what I'm allowed to do in the service, by the way. So that's what I was talking about when I said trusted subsystem. We actually don't want that host to get administrative rights on the machine, so we should be running as a reduced privilege account and then call down to other services that have higher privilege to protect the web tier or the entry point tier. Now, continuing, the security context identity is also Michelle. That's because my proxy, by default, sends whatever my identity is. In fact, I have no code to initialize the proxy, you'll see. I just construct the proxy. Let's find the initialized proxy code. as follows, and it takes my Windows credential and passes it along because the binding says to do so. Now, if I log in as somebody else, like my test user, now I'm logged in as test user on this client application, and when I call, I'm still Michelle. Why? Because I didn't recreate the proxy. If I don't recreate the channel, then the channel is immutable once created. So if you're going to allow people to log in as a different user, guess what you have to do? You have to reinitialize the proxy. So what I'm going to do is I'm going to go to my client app and the login code, and we'll take a look at, there's a function here that's basically showing a dialog, impersonating the user on this client machine so that we run as that new identity that we just logged in as, updates the identities in the UI, and then furthermore, I'm going to initialize the proxy once again. Now, in order to initialize the proxy, I need to do something. I need to set this m_username equals to f.username, which is the return from the dialog, and this m_password equals f.password. So that way I've cached the username and password that was typed in so that when I initialize the proxy, I have that information in the proxy. So let's go ahead and take a look at the code for initialize proxy. Right now, I'm not setting an identity, but I can and must. So what I'm going to do here is I'm going to say if m_username not equal to, how about string is null or empty, this username. So if not string is null or empty, and not string is null or empty, this dot password. So if I've set the username and password, then what I want to do is the following. I'm going to put a block in here where we initialize the proxy's client credentials programmatically. And there is a certificate credential, a Windows credential, a username credential. We're setting currently the Windows credential. And we're going to set that client credential equals new network credential. And the network credential is going to take this m_username and this m_password. So I'm initializing the proxy. Again, I'm setting it up with a different set of credentials if we have logged in as somebody else, just to make sure. Now, after doing all this, which is really to show you something, Windows.client credentials can be set. Do I really need to do that? And the answer is not if I impersonate in the client application the user that logged in. And because I did an impersonation, guess what? All this extra code is not necessary because I'm impersonating. When I reconstruct the proxy, it will take on it will initialize the Windows client credentials with whatever the current process is running as. And by impersonating, I am running as whoever I logged in as. I wanted to show you this, but I want to also show you that it's going to work without because I've impersonated. So in fact, just constructing the proxy will be good enough. So let's go ahead and run it. We'll log in as somebody else, test user, call the user operation, and my security context identity is now test user. My host identity is still Michelle because I run the console as Michelle. And that's that. Now, what about role-based security? Well, guess what? If I want to protect my operations, for example, using principal permission demands, I can do that, security action demand, just in the classic .NET role-based security permission demands. And I can say role equals and built-in administrators for this first call. Right? And for the user operation, we're going to require built-in users. And for the guest operation, we're going to require built-in guest. Classic .NET permission demands will work at the service operations here, and we'll see that as we go through this example. So right now I'm going to log in as test user, which is not an administrator. And I'm going to call the user operation, I get in. I'm going to call the admin operation, access denied, as expected. Now, I may not want to hard code, of course, the built-in administrators and so on. It might be more dynamic, so I might need to wrap this in a custom attribute that looks it up somewhere, but you get the idea. Role-based permission demands work. Okay, so impersonation at the service can also be done. You can, in the operation behavior, say that you allow impersonation, which means if there's a Windows credential, impersonate it, otherwise don't. You can also require impersonation, which means that you actually must press a credential, a Windows credential, and it will always be impersonated. So you're creating an application or a service that depends on impersonation. And then there's not allowed, which prevents administrators from being able to enable impersonation as shown down here with the impersonate caller for all operations. Now, my suggestion, usually if you are not writing a service that is acting as a impersonation service, which I would recommend against, then I would say put not allowed so that administrators can't turn on impersonation for your Windows credentials behind your back, because that means your services will run as whoever called. And if they're an admin, then now you have opened up that service for attack because they're going to have admin rights on the machine, which means if a hacker gets into the process, then it's one less level of security, which is why we don't like impersonation. Now, clients can also protect themselves against impersonation by setting the impersonation level, the token impersonation level, to identify only, which is the default behavior anyway. So you set that on the proxy, windows.allowed impersonation level equals what? You can also say you're allowed to impersonate but not delegate across machines. So if you are doing an intranet application that requires impersonation, you could say it's limited to a 1-machine radius or a 3-machine radius. Typically, you leave it as the default, which is identify me only, but do not use my credentials to impersonate, because that's a risk to administrators that log into the app and to the system as a whole. So let's continue. I have samples, by the way, that do impersonation and show you the set of things that I just discussed. So take a look at those as well in the security directory of the code samples for the book. So continuing, let's talk about business partners and cross-machine calls. So how does a business partner uniquely identify themselves? Let's say that a number of people working at the same company are going to call our service. To identify the company as a trusted caller and to make sure that the users can't call from home, they can only be behind their firewall, you can install certificates and use those to sign messages. So using a business partner certificate to identify callers and still maybe supply a username password as well for the individual caller. But that just makes sure that, again, only those that have the private key certificate installed on the machine can actually successfully connect to the service. The other thing that's useful for is cross-machine calls behind the firewall. And the way it works is, you'll basically have a certificate installed on the client machine into the, probably local machine store. You'll have a certificate installed on the server machine identifying the server. You'll put the public key of the client in the Trusted People store, which is really your authorization right there. So if you turn on something called Peer Trust and you put the certificate in the Trusted People store, then that's going to be your authentication. Here's how it looks. To configure a service certificate, you supply a service credentials behavior as shown here. So we've got a behavior for the service with a service credentials section, and the service certificate identifying the service to clients is relying party key, that's the key I use. You can have whatever the name of your certificate is here. I'm doing a lookup by subject name, but normally you'll do a lookup by thumbprint. It just takes more work because you have to go and look up the thumbprint and put it in there. At the end of the day, this is basically saying I'm identifying the service with this key. So clients will encrypt calls using the public key portion of this key. Now the client can also send a cert using the client credentials section and supplying a key. And I'm using subject key as in the subject of the call, which is a technical term for, a relying party, identity provider, subjects, so forth, which I'll talk about in the next webcast. But that's the key I use, subject key. And that is in the client behavior, which means we associate that with the client endpoint. You can also programmatically initialize the cert, though. Now, another thing that you care about, so I'm talking about mutual cert authentication here, where we have a cert at the client and a cert at the service. You've seen now how to configure both. The other thing that matters is, does the client have the public key for the service so that it can encrypt calls to it? And typically, you don't want to deploy client applications and have to install public key certs in the client machine. So one of the ways to get around that is to negotiate dynamically, like with SSL, and get the key that way. So get the public key in an initial exchange. The other way to do it is to actually, so basically if you don't negotiate the key, what you can do is you can embed a base64 encoded version of the public key. And actually that's what proxy generation does for you by default. When we use negotiation, there are some technical things underneath that I can't spend a lot of time off for time here, but basically there's a protocol called SBNego or TLS-Nego, which are used to negotiate. But the important thing I want you to note about negotiation is that it's not interoperable. So normally, when we configure security for WS HTTP binding, for example, we actually need to explicitly go in and turn off negotiation. If you don't do that, you're not interoperable. Today, negotiation is not interoperable. Speaking of HTTP bindings, another thing related to security in general is that you can establish a secure session. And secure sessions are interoperable, but it's not always possible that every client is yet using those protocols. So it's important to disable that if you're using legacy clients or expecting some legacy clients to call. And you do that by saying establish security context set to false. So negotiation and secure sessions are features of the WS HTTP binding that you need to be aware of. Let me just go through a quick example of mutual certificate authentication, though. So essentially what we have here is, let me actually open a different example, my mutual certificate example. So we've got a service which doesn't have any authentication in the actual service itself. It's just hello indigo. A string will be returned. In the host right now, what we have is TCP binding, and that TCP binding is requiring a certificate from the client. The service behavior includes a certificate. I'm validating using peer or chain trust right now, but what I want to show you is that peer trust is actually more reliable. It just means I have to put the certificate of any calling client, public key certificate, in my Trusted People store. And if you're wondering what is all that, if you're new to certificates, then you might want to look at some of the setup instructions that are available on my web log for the book, because it goes through in detail how to set up certificates and so forth, and even to generate them. So the trusted store location is local machine. The service certificate is RP key. And these are the sections that we have to configure to make a service certificate available to identify the service to the client and to support encryption and signing. So what will happen by default is the client will be configured for TCP binding, and it will also expect in the endpoint that we have installed RP key in my client essentially it's expecting that I have installed the public key of the server in my certificate store by default. So what I'm going to do is show you what happens instead of that configuration when I use WS HTTP binding. So I'm going to go ahead and comment out this particular guy, and I'm going to have WS HTTP binding instead of TCP, because it has some implications we care about. And what I'm going to do is I'm going to say false to negotiate secure service credential and false to establish security context. So no secure session, no negotiation. What does that mean? That means the client has to have access to the public key of the service to encrypt calls, and every call will pass credentials from the client, which is the certificate from the client, and have to re-authenticate because there's no secure session. So it creates some overhead, essentially, because we're authenticating every call, too. Also creates bloat because we're using a private key for every call. Now, given that I've just changed this to use HTTP, what I'm going to do is run the host. And at the client, I'm going to refresh, update the service reference. And what that will do is it will add a WS HTTP binding section, and it will add an endpoint for HTTP. And you'll notice that the identity, which is saying what's the identity of the service you're calling, includes an encoded certificate. Check that out. So we actually don't need to install the certificate of the service in the client machine. That encoded value will be used. Now, because I just created a new endpoint and because the client has to pass a certificate, remember I showed you there's a client behavior to pass the certificate? And so what we need to do is set up the behavior configuration to be client behavior so it will find that certificate. Otherwise, I would get an error saying that I did not provide a certificate. Oops, I think I just tried to run the host twice. Let's leave the host running, and let's run the client. And the client is running. No errors means it works. There we go. Now, why am I showing you this? Let's see what happens when I make a slight change. Let's go back to the client configuration. Go to the app config, and let's take away this identity of the certificate, and instead let's put back the DNS identity of RP key, which is saying it's okay that I'm sending messages to localhost even though the server certificate is RP key. I would not have to do this if I was sending a message to dub.that-indigo-girl and the certificate said dub.that-indigo-girl. It's because the certificate doesn't match the domain that I need to provide a DNS. And that's just a testing issue. So let's try and run it again. And let's run the client. Service certificate not provided. It needs a service certificate in order to do encryption and signing. So you know what I'm going to do? I'm going to change it to negotiation. So we're going to change this to negotiate as true. And I'll even establish a security context, which means that we'll only need to authenticate the client certificate once, and we'll establish a new key for encryption and signing through a negotiation process like SSL handshake. Let's go to the WS HTTP binding configuration on the client, and let me set the negotiate to true and security context to true. And let's try it again. We'll run the host. We'll run the client. And it works. Why? Because it was able to negotiate the public key certificate because I enabled negotiation. Now, I'm not going to go into the trace viewer and show you all of the trace statements because we don't really have time to go through every single detail of trace. But I was tracing that, and I do talk about these details also in the book text. Or you can just enable tracing and try those two settings yourself, replaying the webcast, and you'll be able to see it. The point is that you'll be able to see that we did encrypt and sign the message indeed, and that there were a series of calls ahead of time to negotiate a secure session. So far I've talked about an intranet scenario where we do classic Windows credentials and message protection, transport protection, encrypting and signing over TCP. And then we did a mutual certificate authentication where client uses their certificate, service supplies the certificate, and I explained a little bit about negotiation, in particular related to HTTP binding, because of the fact that we need to understand it's not interoperable. And then I briefly discussed secure sessions. So now we're going to talk about username and password and typical intranet scenario as the final section here. So in an intranet scenario where I have web services exposed through IIS, I'm going to probably use one of two things, either an SSL connection with username password passed with transport protection, which is very common today. 90% of web services do that today. Or we have the ability to use message security to pass the username password, but maybe protect the message using certificate instead. So we use message security instead of transport security. In either case, the username password would be passed in an interoperable way inside the message headers of the SOAP message instead of using the transport header, like HTTP headers. And then in terms of authentication and authorization, usually it's not Windows when you're doing internet. Usually it's the custom database you have. And we can use the ASP.NET membership provider, which means we get for free all those customized tables for username and password. So in terms of authentication of the caller's credentials, there's another setting we put in the service for Windows authentication or username authentication or certificate authentication. So depending if the client is passing Windows username or certificate, you decide how do I want to authenticate that caller. If it's Windows, it goes against the Windows domain. And you decide if you allow anonymous or not. If it's username, by default we use Windows, but we can change it to use the ASP.NET membership provider, which I'll show you now. And then if it's certificates, you saw me point out peer trust. Chain trust means that it's going to do, it's only going to rely on the certificate being validated as a valid cert all the way up the chain, up to the root. And if we use peer trust, it's actually safer because that means you've explicitly put that certificate in your cert store and you trust that caller. So, that's safer than chain trust, just an illustration here. As for authorizing, after we've authenticated, okay, I know who you are, authorizing access is done through the service authorization behavior, again, part of that section. And you can use Windows groups, which is the default, ASP.NET roles, which is what we're going to show next, or custom, which I'll show in the next webcast. What this controls is what is the security principal attached to the thread. And remember, in my first demo, the security principal, the identity of the caller, was set up as whatever the Windows identity was I sent in my TCP demo. When we use a username password, that could also be a Windows credential, or it could be a role provider principal, which is potentially the ASP.NET database that we're going against. Ultimately, what that means is that the system threading, current thread, current principal gets initialized. And this is a .NET concept, not a WCF concept. So we expect that every thread on the server should be initialized with a security principal so that we can do what? Role-based permission demands. That's the only way they work. If we don't set this up, we can't do role-based permission demands. That's that. So with authorization, if we're using ASP.NET, we set that section to ASP.NET roles. And so with that, why don't I give you a quick demonstration of it. So this is my last demonstration here. I have an internet demo. And what this has is a service hosted in IIS. You can see that. And this has a web config with a number of endpoints. And what I want to point out here is that we can use basic HTTP binding with a username over SSL. We can use WS HTTP binding, which is SOAP 1.2 instead of SOAP 1.1. And we can do that with username over SSL. We can do WS HTTP binding with certificates. And when we say one shot, that means we don't do a secure session, like I just talked about. We get Every single call signs and sends the username token and encrypts the message and signs the message with the derived key. And essentially, you re-authenticate those credentials every call, as opposed to establishing a session with WCF. We can also do a secure session with WS HTTP binding, or we can do a secure and reliable session, which means we're turning on reliable messaging, which I'll talk about in 2 more webcasts. Now, these bindings are all set up here. So I've got security mode transport with message credential for the basic HTTP binding, username password over SSL. I've got web service HTTP binding with the same result, which is username password over SSL, transport with message credential. Turning off negotiation, turning off secure sessions because we're doing a bare minimum of WS binding. Then we can turn on, we can actually just use username, password, and message security, which means we're relying on the message to encrypt and sign instead of the transport, which means we have to supply a service certificate. But still, no negotiation, no security context. We can have a secure session, which means we enable security context. And we can have a reliable session, which means we turn on reliability, which I'll talk about in a couple of webcasts. The point I'm trying to make here is that, using SSL can be done with either basic or WS HTTP binding. Classic username password over SSL is very common. The choice between the two would be based on, do you want SOAP 1.2 or SOAP 1.1? And then typically WS binding has additional features we like the ability to do a secure session or a reliable session, or both. And then lastly, you might just want to use certificates to secure the message without using the transport. No SSL, just message security, and you can do that with basic or HTTP binding. Now by default, I'm doing Windows authentication and Windows authorization. So you'll notice the username authentication mode right now is Windows. And remember I said there were some choices, membership provider or Windows. And for authorization, we have Windows or ASP.NET roles. I'm showing you the defaults first because I want to run this illustration where the client is I'm going to log in as a user account, test user, which is a Windows account, by the way. And I'm going to call that service using SOAP 1.1 over SSL, which means I use the transport header. Oops. I'm calling the admin operation, and I'm not an admin. So the user operation was called. Notice the host is running as network service. That's because I'm running an IIS. My principal identity is test user. My Windows identity is test user. Those are available off of the security context that I showed you before. And the thread identity is test user. So I've initialized the server thread so that I can do role-based security against my Windows account test user. In fact, I'm doing that. You saw that access denied, right? I'm doing that using role-based permission demands. There we go. I've got a built-in check for built-in administrators right here, and it only works because we created a Windows principal and attached it to the thread. But we didn't do that. It was done for us using this little setting right here. Use Windows groups. Now let's make a change. I'm going to call ASP.NET role and membership provider. And we'll rerun the client. I'm going to log in this time as admin. And this is one of my custom accounts inside my ASP.NET database that I've set up. And now we'll call user operation and look at what happens. I'm running as network service at the server. That's what the host identity is. The principal identity is admin. There's no Windows identity because we didn't get a Windows principal. We got a regular role provider principal, which just means that my role-based checks are not against the Windows domain. My role-based checks are against the ASP.NET provider now. Why? Because of this little guy right here, membership provider. Use ASP.NET roles, authorization. And I can call any of these guys, and it really really just means that the wire has changed. I'm using a secure session or not. I'm using a reliable session or not. And those details obviously change some of the semantics. But in terms of authentication and authorization, because I logged in as admin, I get to call admin, I get to call user, but I can't call guest. Access is denied. Permission demands are working because I have stacked both the custom permission demands and the Windows permission demands. So with that, what I've done is really summarize the last part, which is setting the credentials. You've seen how to set the credentials on the proxy. You can set Windows username or certificate credentials on the proxy based on what the server requires. You've seen how to set a client behavior to send a certificate. You've seen how the proxy generation encodes a certificate at the client to avoid negotiation for HTTP. On the service, you've seen how to configure required credentials from clients and how to configure the behaviors for authentication and authorization, which default to Windows. As for certificates, unless you map the certificate to a Windows credential, we're really just using peer trust, most likely, to authorize access. And once you get in, you don't do role-based permission demands on CERT. But you've seen that I've been able to do role-based permission demands using classic .NET security, using principal permission against the Windows domain or using ASP.NET. So that's a lot to chew on, I think, for 1 hour. There's a lot more details we could get into. Certainly I can spend a lot more time explaining how secure sessions work, what the protocols are for negotiation and so forth. If you have those types of questions, you're welcome to email them to me. I do have numerous other examples in the book code, so please go ahead and get those as well. In the next webcast, I'm going to talk specifically about claims-based security related to WCF, so that's going to be another deep topic. And again, if you need more information or need to absorb this a little bit more carefully, I think my security chapter is about double the size of all the other chapters in the entire book, so you might want to take a look at that too. And again, all the code is at thatindigogirl.com. So with that, I'll take a look at the questions, but I'll turn it back to Tracy. And thanks very much for attending today's webcast.
Excellent. Thanks so much, Michelle. I do want to remind everybody that for more information, they can print a PDF of today's session. To do that, just go to the File menu in your upper navigation bar. Now's a good time to submit your questions into the Q&A panel. You just want to type them in and hit that Ask button. Also, please do take a moment to fill the survey out. I'm going to launch that here in just a moment. As a reminder, for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcasts. Now you can go here to access this webcast, which will be available for download in about 24 hours. Now if you have any webcast content ideas, something out there you want to see and you haven't yet, we would love to hear from you. Just take note of this link here. And here is a survey from our session today. Please follow the links provided to complete today's webcast evaluation. And Michelle, do we have some questions waiting there for you?
Yes, we do. I did answer one already in text, so please do take a look at the text answers as well. Somebody is asking me why access denied happened when I called guest as admin. That's because admin is not in the guest group, and the guest count is disabled, yes, on this machine. Why did I put protection level on the implementation? No. The protection level is set on the interface, not the implementation. So you'll notice I have an interface describing the service contract, and that is where the protection level setting on the operation contract is. Can WCF use SQL Server authentication or pass SQL usernames and passwords? Yes. So WCF has nothing to do with that. If I set up the ASP.NET membership provider, it's going to use whatever my local SQL Server connection string is. And those things are configurable using ASP.NET configuration settings. So I didn't get into all that. There's lots of ways to customize the membership provider if you have a custom database, if you need to use a different connection string. But I do have detailed discussion of how to set up the connection string in my on my weblog where you download the book samples. You can also get instructions on SQL Server settings. Now, can you use username and password instead of Windows? Yes. But I never recommend using username and password against SQL because it's more secure to use Windows credentials in order to better protect, I guess, the credentials that you're using. So that way what happens is, for example, my services that are allowed to talk to SQL Server tables 1, 2, 3 will have a table 1, 2, 3 user, and the services run as that user, and that user will be installed for those tables in SQL Server instead of having a place where I need to hard code and or encrypt a username and password that I'm putting into my connection string. So it's just a little bit more secure to go with that. Does impersonation affect the certificate? No. So you have to clarify, I guess, if it's a client or server certificate. If a client passes a certificate, then that certificate might be mapped to Windows credential or not. If you say you want to map it to a Windows credential, then you could impersonate that caller. But again, I wouldn't recommend impersonation. And having access to the keys, very good question. So when you configure a server certificate, and I talk about this also, I have a detailed setup, configuration and setup document for all the book samples on my website. So when you read through that, you have to follow those instructions to the letter because they tell you how to create certs, how to install my certs, how to use find private key to provide the rights to access the certs, because when your services are running, they have to have the right to the private key store or the private key that they are trying to read. So those instructions are all in there. Somebody's asking, difference between a secure session and a reliable session. Well, reliable sessions I'll be talking about in 2 webcasts. The short story is a secure session just means instead of me passing my credentials, let's say username, password, and the server has to re-authenticate every single time. What would happen is we'd negotiate a session on the client and server in the channel layer whereby we're using a session identifier whereby, although I'm still encrypting and signing to identify myself, I'm using a shared key or a shared secret we have generated, which is smaller than a private key, so that's also reducing the bloat. But it's also reducing the overhead of authentication at the server because instead of re-authenticating, it looks up the session and sees that it exists already. So reliable sessions is nothing to do with that. Reliable sessions has to do with the reliability of sending messages, and if you have a transient network hiccup, how do I retry, resend so that we still get the message across? And that I'm going to talk about in 2 webcasts. Somebody's asking if they develop a WCF service as an intermediate router using WS HTTP binding, Windows credentials, with the client, router, and target service on the same machine. The person is saying that they get unable to verify security token when the router passes the message. You know what, you should probably email me this question so we can talk about it further because this is pretty detailed and routers are another really fun topic and require some effort, if you will. So we might need to talk about your configuration settings. So please do follow up with me in email. I think the person asking this is Rich. What do we mean by impersonating of a service? What we're talking about is impersonating the caller, not the service. So I hope I didn't say that in a confusing way. The caller sends a credential, a Windows credential, and the service can impersonate that credential for the duration of that call. So every call to a service gets its own thread, and that thread impersonates the caller. So if it's an administrator calling, that means that thread operates as administrator for the duration of its call, which means if a hacker gets in, they get to be administrator on that machine, and that's a scary thing. Okay, another question, and this is the last one, I think. Can't use Windows Token Role Provider with WinForm Client and HTTP WCF service. When IIS is set to anonymous, then get roles for user acts on iUser machine. When IIS is set for Windows, then the WinForm can't get through because it doesn't handle the NTLM challenge response. Okay, you know what? I think we should email on this one because, again, it's going to take a little interaction for me to work with you on the answer. So what I'll tell you is the two things that people just asked that require some detail, I'll blog the answer when we get to a resolution on the discussion. So that way everybody else doesn't lose out. So just keep an eye on the weblog for that. But I think, Byron, just please email me and let's discuss it offline because it's just too much detail for right now. I think we have to wrap up. So thank you.
Excellent. And with that, I do want to extend a very special thank you to you, Michelle, for your presentation today and answering all the great questions we had come through the queue. Well, ladies and gentlemen, this is going to conclude today's session. I do want to thank you again for joining us. You may now disconnect from the audio portion of today's presentation.